All right, let's talk about percent yield in page 11. So I've already given you in the stoichiometry page 8 number 5 question what the equation was for percent yield, but let's remind ourselves of it. So percent yield equals the actual yield, meaning whatever you get in the lab over the theoretical yield. This is like the perfect yield. If you did a perfect experiment, it's what we calculate when we do a stoichiometry problem. So I say, how many grams of this could I make? That's theoretical. It means I could make 20 grams, but I actually only ended up making 18 in the lab. Well, when we do that, just like in class, we do a percent yield. It's kind of like, if you think about it like that, think about it like, so like let's say I had a test that was worth 100 points. The theoretical value, is 100 points, right? You could have gotten 100. You actually got 80 times 100 means 80%. So we're going to go and we're going to round to the hundredths place. So that's going to be where we end up on that, okay? So let's do some problems on page 11 and take you through that particular process, the percent yield process, that is. Okay? So here we go. It says, write out the equation for the reaction of iron 3 phosphate with sodium sulfate to make iron 3 sulfate and sodium phosphate. So the first thing I got to do in number 1 is I got to write out a good chemical equation, right? So here we go. Well, FePO4 was iron 3 phosphate, plus 3 for iron 3, minus 3, because phosphate always carries that charge. So, plus 3 minus 3, you're good. Plus sodium sulfate, Na, plus 1, SO4, minus 2. Therefore, Na2 plus 1 to cancel out the negative 2. And I'm just getting rid of my charges because I think it's cleaner that way. So that's Na2SO4. Then yields Fe and SO4. This is still plus 3. This is now minus 2, right? So therefore I need 2 of these, plus 3, and I likewise need 3 SO4s. Negative 6, positive 6. Cancel each other out. And Na3PO4. Why is it Na3PO4? Because you need a plus 1 for the negative 3 of the phosphate, right? So there you go. Alright, so that's number 1. We got to balance it, right? So initially what I said to myself was, okay, I'm going to try a 2 right here. When I do that, it makes me put a 2 right there. That gives me 6 sodiums. Well, I need 3, so 3 times 2 is 6. 6 sodiums. That gives me 3 SO4s, 3 SO4s, 2 Fes, 2 Fes, and we're balanced. 2 PO4s and 2 PO4s. So there's your balanced chemical equation. Number 2 says, if I perform this reaction with 25.0 grams, so 25.00 grams of FePO4, and in excess of this, yeah, I'm telling you what the limiting reagent is. So, how much iron 2 sulfate can I make? So what is the mass? So you start with the limiting reagent, 25.00 grams, and the first thing I recommend you do, turn it into moles. So we can do a mole ratio. So, grams of FePO4 in 1 mole of FePO4. Well, you go find the molar mass, you add Fe and P and 4 oxygens, you get 150.82. Remember, we always round to the hundredths place on molar masses. So 150.82, which brings us to the most important step, the mole ratio. We want to compare moles of FePO4 to moles of what we want to know, which is FeSO4 3. So it's Fe2SO4 3. And the numbers that go here and here come from the balanced chemical equation. So FePO4, there are 2 of them. So there's a 2 there, that 2 came from right there. And for FeSO4 3, there's a 1. Alright, so now I got to know, okay, in 1 mole of Fe2SO4 3, got to figure out the molar mass of it. what is the grams of Fe2SO43? Now that's a nasty molar mass, right? Because you got to take 2 irons, 3 sulfurs, and 12 oxygens. You do the math on that, it's pretty big. It's 399.91 grams, right? You multiply the tops across, you divide it by the bottoms across, and you get, we had 4 significant figures to start, so the answer is 33.14 grams. What is that grams of? Fe2SO43. So that is the final answer for question number 2. Bring us to question number 3. It says, okay, if 18.5 grams are actually made, so remember, this right here, guys, is the theoretical value. This is the perfect yield of Fe2SO4. But in number 3, we're saying that we actually made 18.5 grams. So 18.5 grams is what we actually got when we did the lab. And I will always tell you that number. You should have gotten 33.14. Again, you will always get this from a problem that you calculate. Times 100, why? Because it's a percent yield. So that equals, we are going to round to the hundredths place. So therefore, the answer is 55.82%. Round to the hundredths place. Question number 4 says, is the answer from problem number 3 reasonable? And it also, therefore, goes on to say, explain. Well, 55.82, I mean, if you were in our class, it would be 56%, and that's a failing grade. So for number 4, what I would say is it's low. Do the lab again. And we're going to do number 5 together in class.